All right, what's up, guys? Mr. Rushka here, okay? 5.7 notes should be pretty quick, okay? Let me whip through this so you guys can spend your weekend watching TikTok or playing Fortnite or whatever the kids doing these days. Okay, so first example, find the relative extrema for this polynomial function here, okay? So right before what we've been doing, right, we've been making a sign chart for f prime of x, which I should probably figure out what f prime is first before I do this. Right, we've been making a sign chart. What is this? Plus 15x squared. Yeah. And then we take out, what, 15x squared? And that's x squared, what is that? Minus x squared plus 1, right? Yep. So we've been finding all the zeros of f prime. That's 1 plus x, 1 minus x. Okay, we've been finding all the zeros. And then, so that'd be x equals 0. All right, so we've been finding all the zeros and undefined points of f prime, putting them on a sign chart. So -1, what is this? 0, and then 1. And then I know from pre-cal, yeah, I know we all learned this in pre-cal. What is this? This is a 4th degree polynomial, so it'd be minus. Then we go through plus. This would be plus. And this would be minus. Okay, so we've been doing a sign chart. Okay. All right, and then all the relative extrema would be the points where the first derivative changes sign. So here, the pink highlighted point, right, that's a critical point, but not an extremum, because the extrema are only the spots where f prime changes sign, okay? This is 0 right here, but it doesn't change sign. It goes positive to positive, okay? So this is how we'd use the first derivative test to find the relative extrema. This lesson is all about using the second derivative test, which can be a little easier, okay? So let me get rid of that. Okay, we're gonna use the second derivative test, which is right here, okay? It's actually really easy, okay? So first what we do, we actually do find all the zeros of f prime. Okay. Okay, sorry, I literally just did this problem. I apologize. Okay, so we do find all the zeros. So that gives us x equals 0, x equals 1, x equals -1. These are all the zeros of f prime and undefined points. Okay, these are all the zeros of f prime of x. Now, instead of making a sign chart, what we can do to classify all of them is we can use these two rules. Okay, we can use those two rules, okay? So instead of doing a sign chart, what I'm going to do is I'm going to calculate f double prime of x, okay? That's going to be, what is that, minus 60x cubed, plus 15, plus 30x, sorry. Right? Yeah. So instead I can just calculate the second derivative. Okay, let me factor that, simplify it down a little bit. What is that? Minus 2x. There we go, minus 2x, right? Yeah, right? Cool. No, that should be minus 2x squared, sorry. Okay, that's it. That's the right one. Cool. Okay, now, instead of making a sign chart, what we can do, and I'll highlight these in yellow, we can just plug all of our yellow zeros of f prime down here into f double prime to classify them, right? So let's do that, okay? So f double prime of 0 would be 0, right? Okay, f double prime of 1 would equal, what would it be, 30 times -1, right? Which equals -30, okay? And f double prime of -1 would be, I think, negative that, right? It would be -30 times -1, which is positive 30, okay? So this is less than 0, this is greater than 0, this is equal to 0, okay? So now instead of making that sign chart, okay, we can just use, let's use this, f double prime equals 0, okay? Knowing what f double prime is, we can go up to this 0 of f prime of x and know that instead of having to make a sign chart and look at the sign chart and say, okay, f prime of x doesn't change sign at x equals 0, we can simply tell ourselves with this information right here that f of x has a crit point at x equals 0, which is not, right? Which is not an extremum, okay? It's not an extremum, okay? Because in order for f to have a relative maximum or minimum, the second derivative has to be either greater than or less than 0. If it equals 0, then it has neither a relative minimum or a relative maximum, okay? I think that's true. Anyway, yeah. Yep. So then let's look at the second one. So x equals 1, we can use this. All right. At x equals 1, we know f has a critical point at x equals 1 because x equals 1 is a 0 of f prime of x. But, right, is it a relative max? Is it a relative min? We don't know, okay? Instead of making a sign chart, we can use the second derivative test, okay? If f double prime of c is less than 0, then f is a relative maximum, okay? This second derivative is less than 0, so x equals 1 is a relative max of f of x, okay? And then similarly, right, we can use, for x equals -1, we use this, right? The second derivative is positive. We know that x equals -1 is a relative min of f of x, okay? Easy money, okay? So it can be a lot easier than making an entire sign chart, for f prime, okay? Good stuff. Okay, slow down if you need to. Okay, here's the actual graph. We can confirm. Okay, right? Relative max, relative min, relative max, and then neither right here. Okay. All right, let's go to example 2 so we get through this video. All right, they give us this chart down here. Okay, and then they use these two. The fact that they use those two. They use that fact to tell us that these are the only zeros of f prime. And then they use this statement to tell us that these are the only zeros of f double prime, okay? Good stuff. Okay, so we want to identify all the values where f has a relative minimum. So what's that going to be? The possible candidates, right? The candidates for this are going to be, right, everywhere. It's going to be everywhere. It's going to be all the x where f prime of x equals 0 or undefined. Okay. So the candidates here, right, is going to be 0. We look at the f prime row right here. We're looking at 0, 0, and undefined. Okay. So let's look at this. Okay. So we have 0, 0, and undefined. Okay. So there you go. There we go. They want us to justify that using the first derivative test. Okay, so this is going back to the last section, right? First derivative test means f prime of x, f prime of x changes sign at relative. So these are all our critical points, what I just circled in blue up here. These are all our critical points. We have to classify them by seeing if f prime changes sign at, I don't know what I was trying to write, sorry, at critical points. No, I was trying to write relative max and min. Michael, Ryan, you guys might break. I don't want you guys to run into anything over there. Please stop. Thank you. Cool. You can toss it over here if you want or something. Yeah. All right, cool. Sorry. Yeah, over there, that's fine. Yep. All right, okay, lost my train of thought. Okay, so let's see if we have all our candidates. It's gonna be x equals -1, okay? I'm looking at this. X equals -1, x equals 3, and x equals 7. Okay, these are all our candidates for where we have a relative minimum. Relative minimum is where what happens? That's where f prime of x changes from minimum would be minus to plus, from negative to positive, okay? So let's see, x equals -1, the x equals -1 column. F prime changes from positive over here to negative over here, okay? So that's not a relative minimum, okay? So that one's not gonna work, let's cross it out. X equals 3, let's look at the x equals 3 column. Here's F prime, it changes from negative to positive, yay, okay? So there we go. That's going to be a relative minimum. And then at 7, F prime changes from positive to positive. So that's not going to be, that's actually not going to be a relative minimum or maximum. It's just a critical point. So this is our answer. X equals 3 is a relative min, right? And that's because F prime changes from negative to positive there, okay? Now let's do B. Identify all x values where F has a relative maximum, okay? So again, the candidates are going to be the exact same, okay? The candidates for this are going to be everywhere where F prime equals 0 or undefined, just like above, so it's the same point still. X equals -1, X equals 3, and X equals 7, okay? So let's think about this, okay? Now we're going to justify using the second derivative test, okay? So instead of having to see whether F prime, instead of looking at just the F prime row and seeing if F prime changes sign at these 3 candidates, we just need to look at the second derivative, okay? So right here, this first candidate, x equals -1. The second derivative is negative. What does our box say? If the second derivative is negative, then it's a relative maximum. Okay, so this x equals -1 is a relative maximum, okay? X equals 3 we already know from the first point, from the first part is a relative, it's a relative min, but let's just use it as an example, okay? We know it's a relative min, not just from the first derivative test, not just from looking at how F prime changes sign there, but also from looking at that second derivative there. The second derivative is positive, so it's a relative min at x equals 3, okay? And then at x equals 7, that second derivative is 0, which is neither negative nor positive, so that's not going to work. So this is our only answer here, all right? It's a relative max and we have to justify using this second derivative test since f double prime of -1 is less than 0, okay? Good. Identify all x values where f has a point of inflection. What's a point of inflection again? Let's look in our notes, okay? That's what I tell kids. Look in your fracking notes, okay? Gosh, dang it. Okay, anyway. Point of inflection is an ordered pair where a graph changes concavity. The test, if C is a point of inflection, then either f prime, double prime equals 0 or undefined, okay? Or f is not differentiable at x equals C, okay? Good stuff. So we're looking for a point where it changes concavity, okay? So we're looking for a point where the graph changes concavity, okay? For the f double prime. So f double prime equals 0 right here at x equals, I'll change colors, at x equals 1, okay? Right, f double prime is equal to 0 there, okay? This is where f double prime, right? F double prime changes there, okay? All right. F double prime changes sign, so x equals 1 is point of inflection. And that's since f double prime of x changes sign at x equals 1, or since f of x changes concavity there. Okay, there you go. D, okay, I don't know how this one has anything to do with this, but it's just like a little derivative thing. What is the equation of the tangent line to the curve y equals f of x at x equals 5? So we have an x, okay, we need an entire point, so we need a y. Okay, what's y going to be? Y is going to be f of 5. So that's going to give us our point, okay? And then our slope is going to be f prime of 5, and so our equation in point slope form of the tangent is going to be y minus f of 5, or y1, equals f prime of 5 times our x minus our x1, which is 5, a particular x they gave us. Let's do some calculating here, okay? So x is 5, okay? Let's look at the x equals 5 row, okay? F prime is equal to 3, or f of x is equal to 3 there. So f of 5 equals 3. Okay, so our point is 5, comma 3. All right. And then f prime of 5. Look at the f prime row. F prime of 5 is 2. Okay. So our m equals 2. So our answer here is y minus 3 equals 2 times x minus 5. Okay. And they said the equation, they didn't ask for slope-intercept, so I'm just going to leave it in point slope here. Okay, guys, so do the 5-6 and 5-7 skill builders for Monday. Slow down this video if you need, if I went too fast, okay? That's the beauty of videos.